Okay, howdy hawks. We're going to take a quick look at complex numbers. Okay, so first let's just talk about the numbers that we do know. We know whole numbers, or integers, right? That would be numbers like 1, 2, 3, 4, 5, and so on. Right? And then this was good enough for a while. And then we had to learn, and this includes negative numbers as well, -7, so on. But we also get the rational numbers. Rational numbers are any numbers that can be represented as a fraction. And note that any of these can be, right? Like we can put this as 5/1, right? That's a fraction. So these are all rational numbers, but we got some new numbers in there too, right? Like 2/3, 5/7, -13/20, and so on, right? So those are our rational numbers. And we're going to give these things special symbols, right? So these are the symbols we usually use. Integers, rationals, right? Along with the rationals, you get irrationals, but we're going to do the next inclusion, right? So irrationals, these are not irrational, but we're going to throw in the irrational numbers, right? -√3, pi, and so on, right? These are numbers that cannot be represented as a fraction, or what the irrationals are. But we're going to include this in a larger group, so we're going to put the rationals and the irrationals together. And then this is all the numbers that we've learned so far. And these are called the reals. Okay? We're going to add another group. Oh, and let's point out that the irrationals are another thing. Right? And the irrationals are a part of the reals, but they are not a part of these. Okay. And this has been everything we've needed so far. In fact, this has been everything that was needed for the human species for a couple thousand years. Right? And in fact, humans were able to function initially with just these. We didn't actually even use fractions. The problem is, right, like if I say 2x = 1 and I want you to solve that, right, you're going to be able to figure out that, oh, x must be 1/2, right? We're able to solve this, and the answer is a rational number, right? If I say x² = 2, right, we can solve that, right? That means x is either the positive or the negative square root of 2, right? We can get that as answers. But here's the issue. We have now encountered a problem where none of these numbers, there's no real number that work. And when I say real number, I don't mean real as in the sense of fantasy and fiction and stuff like that. I mean a real number as in this definition, right? A number that can represent a real quantity in the real world, right? You can actually have the square root of 2 feet, right? You can actually have the ratio pi is used in the real world all the time to relate circles to the diameters, right? All of these numbers can exist in the real world. But there is no real number, right, that will make x² = 2. But then what do we do when we have x² = -4? Right? What do we do in this situation? Well, we had a mathematician who defined what it means if you have a negative number. He said, well, you know what, we're gonna create a name for the square root of a negative number, and what we're gonna call it is, and we're gonna define it two different ways. X² = -1. We're gonna call this x something. We're gonna give it a name. We're just going to call it I, and I is for imaginary. I squared equals negative 1. Okay, and another way of representing that is the square root of negative 1 equals I. Okay, so when we take the square root here of negative 4, right, we just want to get x by itself. Well, we know the square root of 4, right? That's just 2. And we know the square root of negative 1 is I. So the square root of a negative number, the square root of a negative number is the same as the square root of a negative number. We just have to put an I out there too. There's actually two answers that would work, right? This is one answer, but just like if we had x squared equals 4, right? X could equal 2 or negative 2. Here we're going to get x can equal 2i or negative 2i. And you'll see if we multiply these together, right? Negative 2i times negative 2. Negative 2 times negative 2 is 4. I times I is I squared. But remember, I squared, that's just negative 1. So this is really 4 times negative 1. So this is just negative 4. Okay? So we're going to get into adding and subtracting and multiplying complex numbers. But for we didn't talk about what a complex number is. Okay, so this is an imaginary number, right? The whole thing is imaginary. This is an imaginary number. This number over here, negative 4, this is real, right? This is a real number. It's not imaginary. And remember, when we say real and imaginary, we don't mean that imaginary numbers are make-believe. It's just a really unfortunate name. I don't know why they call them imaginary numbers, because they do exist. They just can't be used to measure a real quantity. 2 and negative 2, those are real numbers. Okay? So let's just write down a little bit of this. I think we have a little room at the top. We do. Okay. So let's just write down a little bit of this. We have two categories now. We have real. We have imaginary. And this includes, any number we can think of. Any number. And this includes any number we can think of. But we're going to add the square root of negative 1, so we know that it is imaginary. And notice on this one I put the I in front of the square root, because if you put it behind the square root, it's hard to tell, is the I inside the square root or not? So if you have a variable or an I, usually you're going to write it in front of the square root to make it a little easier to read. So what happens if we add two of these together, right? What is 2 plus 2i, right? Here we have a real part and an imaginary part. Or what about the square root of 4? That's just 2. Okay, what if I did 3 plus I root 5, right? What are these numbers, right? They have a real part and an imaginary part. Okay? These are called complex numbers because they have a real part and an imaginary part. We decided to give them the name complex. How do we understand these? All right? Well, real numbers, you have the real number line, right? There's 0, right? Any real number, you can just put it on this line somewhere. Okay? This is our imaginary number line, okay? There's the real, there's the imaginary. So if I were to plot the number 2, that would be easy. 1, 2. Here's the number 2 on the real number line. If I wanted to do 2i, that's not too hard. 1, 2. Here's 2i. It's on the real number line. If I wanted to plot 2 plus 2i, a complex number, well, it's not on the real number line because it has an imaginary component. It's not on the imaginary number line because it has a real component. Instead, it's right here. So there is no complex number line. Instead, we get a plane. right? Where the x coordinate is the real number and the y coordinate is the imaginary number. So this point right here, which normally you would want to call 2, 2, since this is the complex plane, we actually just call it 2 plus 2y. Okay, and this is one of the classic ways of representing complex numbers, right? And we'll talk about what this means and we'll play around with this. Your question that I want you to think about, and we'll keep this easy. Don't want this to blow your brain up yet. So my question for you is just, right, if x squared equals -9, then what does x equal? If x squared plus 5x plus 20 equals 0, what does x equal? And just so you know what the answers are going to be, this one's going to be imaginary. This one is going to be complex. I'll be very happy if you can solve both of these. This one's a bit tougher. So if you get stuck on this one, don't beat yourself up. We're going to come and take a look at this one again on Thursday. But see what you can do with this one. And that's it for now. I will see you guys later.